Okay. Canny edge detection. Why does it matter? So the clankers, they really like they look at this picture and they say, I don't know what I'm looking at. There's a lot of colors, there's a lot going on. How are they supposed to know what to do with this? But then if you do some canny edge detection, they can look at this and they see lines, and they see rectangles, and they say a lot of black area, and they're like, oh, that's good. I'll just drive in that area. So it's really good for that kind of stuff. Going down a hallway, you can see like the edges of the hallway. It's really easy to detect that, all that kind of stuff. He likes that a lot better than this demo. Okay, so this is my code. I'm gonna run it now. So first we blur the image. So now it's blurred. And next it's going to do the sobals, the X sobal and the gradient intensity. So you can see you got your sobal X, your sobal Y, and your intensity. Next, it's going to take the those and it's going to thin them based on the magnitudes and the directions. And finally, we go and we get rid of all of the lines uh, that were not bright and not connected to bright lines. And then this is our final image. Looks pretty clean. We got lots of details, but not too many details. And then this is what CV2 came up with. That's it. You can also see this one is very clean. They have more details probably because of um, just how they handle the what do you call it? Just how they handle that kind of stuff. Um, so how does canny edge detection work? For each pixel, you look at the direction of most change for each pixel, and then you check, is that pixel bigger, like a brighter, basically, than the two pixels adjacent to it in this direction of most change? And if it is, you keep it, and if it's not, then you get rid of it. Things that went bad. This program, basically, this is the apply kernel. I had it set to do integers, and I had it set so that if anything was negative, it would just make it 0. That's bad because you kind of need floats, and if it's negative, then it makes it so your angles will only be between 0 and 90 degrees. That gets rid of a lot of data. Don't know where my pictures went. My pictures are gone. Um, but you need things more than that. So you can see here, this is what it was giving me, the bad one. You see you lose a lot of details in here. Like the text is completely gone. Overshield bar gone at the top. Fixed. Now you can see a lot more details. You can read the text. Everything's better. Parameters. This is what I was talking about earlier. You got your weak pixel and strong pixel, weak pixel, strong pixel. Um, Basically, this determines what is bright, what is really bright. Um, yeah, it's really important because you can see in this one, you got a lot more detail, which can be really good, or it can be really bad because if you have too much detail, it's hard to process, you don't know what you're looking at. And if you have too little detail, then you don't get anything out of it. Like in this one, you have less detail, but say you're just trying to read text, bam, you can still read the text. So could be good. Takeaways. It takes a long time to process a small image. So it needs a lot of optimization. Somehow CV2 does it. I don't know how they do it. If I was to do this like with more stuff, I would implement variable thresholding because I think that would be cool and I can get more detail. I want to make something like train a model to keep track of where all the dog poop is in my backyard because I have a lot of dogs and they poop and we don't know where it is. That would be pretty cool. For actual use, you would need a lot of optimization because actual cameras run at a very high frame rate, and taking minutes to process each frame is not very ideal. So it needs a lot of optimization. One cool thing I just did this. I wanted to show it off. My hysteresis function was not doing good. It was bad. So I found this thing online called the depth first search. So instead of going forward and then backwards through the array, you basically find a strong point and then you trace all of the thin points until there's no more thin points. It's pretty cool. I like it. Um, yeah, I just wanted to show that off because I like it a lot. I'm quite pleased with it. It works really good. Makes all of my curvy lines show up where they before they were not showing up. Um, anyways, that's uh, searching for things in images. Pretty cool. Goodbye.